So, welcome back. This is another episode of Conversing Labs. This is Reversing Labs podcast that brings you face to face with the top minds in threat hunting, reverse engineering, threat intelligence, software assurance. And I'm your host, Paul Roberts. Really happy to be back with you again, and happy to have back with me in the studio Reversing Labs' own Carlo Zenke. Carlo, welcome back.
Hi, Paul. Glad to be back.
Carlo is a reverse engineer and researcher here at Reversing Labs. Carlo, could you just tell the audience a little bit about what you do here?
Well, as you said, I'm a reverse engineer here at ReversingLabs. My daily tasks come down to analyzing various software solutions and file formats which we get from our customers and from public repositories, and looking for interesting stuff in those file packages and similar file formats.
That sounds like a fun job.
Yeah, it has good days and it has bad days like any other job, but it is mostly interesting. It's not boring, never boring.
No, especially not these days. So, Carlo, we had you in Conversing Labs, I think back in May, to talk about dependency confusion attacks on NPM. You had found a whole bunch of those. It ended up being kind of friendly fire or a red team exercise by a German consultancy on other German firms. But today we're here to talk about another NPM-related software supply chain attack. This one seems to be for real, and we wrote about it a little earlier in the month and dubbed it IconBurst. Could you tell us about IconBurst, like what it is and how you managed to come across this in the wild malicious software supply chain attack?
Well, first, what makes this different from the previous attacks we talked about is that it's not targeting developers which use the packages, but it's targeting the end users of the applications which the developers create. So it's a bit different. And what's specific about it, it's generally gathering form data from web pages. So it searches for DOM elements with various types of form tags, classes, or ID, however you wish to find, depending on the package version. And then it collects that data and sends it to attacker-controlled C2 server. So how we found it? Well, as you mentioned last time I was here, we talked about friendly fire, red teaming tools targeting German companies, and these tools used specific type of obfuscation, tool named JavaScript Obfuscator. Public available tool which can be used for free. So we created behavior indicators
Looking for that
inside
tool.
our tool, which can be used to detect that type of behavior. So when you encounter a JavaScript file or any other type of file which uses such obfuscation based on our detection rules, we will mark that behavior and link it to that package. So you can search the analyzed packages and pinpoint which ones have that type of behavior. So what we do, we continuously monitor new packages that get published to public repositories, analyze them with our tools, and look for various behaviors, including this one. So I specifically looked continuously for that behavior, and in one moment, several packages occurred which had this type of behavior, and looking closer at them showed that they weren't as innocent as they behaved, as they tried to look. Another thing that caught my eye is that all had a similar name. Most of them were named icon this, icon that, an icon So I did a bit of Googling and found that this was a legitimate tool published by Ionic.io, I believe.
Mm-hmm.
And it is a popular icon set for front-end developers in web systems. So I looked into more details and detected, as already mentioned, form stealing tools.
So you started looking for this this use of this obfuscator, found a bunch of packages, and then you looked at those packages and realized there was a lot of similarities in just the naming of these packages. Did a little bit more research and figured out these names are all pretty similar to a very popular icon package used in front end development. So those, I guess, for you as a researcher, are all sort of red flags, right? The sort of what's going on
Yeah,
here. You're moving towards a conclusion as to what's going on.
yeah. The first thing you notice is the obfuscation, usage of obfuscation. Then, okay, obfuscation on its own isn't necessarily malicious, but I would say 50-50% of packages is using it for legitimate purposes in NPM, and another half is using it for malicious purposes to hide its malicious behavior. So when you find that packages, daily you get 5 to 10 packages with this type of obfuscation, you should definitely spend some time of analysis because you have good chances that you'll find something malicious.
Right.
Okay, after that, you look at package names. That's the first. One popular method is typo spotting, which was used in this case. So the attacker changes one or two letters and hopes that someone will mistype it. Another thing that you can search is version numbers. You can see if unexpected version numbers occur and you detect that type of behavior and say, okay, this is red flag, this could be malicious. So that is how we mainly find interesting things. In this case, we did that.
And just to sort of frame this for the viewers, how widespread was this attack? How widely used? Or obviously there are a lot of open source modules out there. Most of them are not widely distributed or don't have a lot of dependencies. What about in this case with these IconBurst modules?
Yeah, in this case, well, typically when you look at npm packages, you want to see how often it's downloaded. And if the package is downloaded, let's say one of its versions is downloaded 50, 60 times, that is usually just mirroring sites collecting that packages to their hosting places. So if you have a package with download count about 50, it's not very popular package. But in this case, one of the packages had more than 17,000 downloads. So that's quite a number.
Lot.
Because that's 2 zeros more than the usual default download rate. So you can't tell by the download number count if it was from 17 different users or anything, but you can expect that if you have 17,000 downloads, that good part of it will be innocent downloads, not knowing that this is actually malicious. If you have 100 downloads, okay, you can expect these are testing
people like you, basically.
Yeah, you can expect that are security research things. But 70,000, you have a broader community which is using this package in any way.
And you talk about 17,000 downloads. Like, is that in your mind? Again, developers looking for this Ionic icon package and just searching quickly. You know, the malicious package is coming up in their search results, and they're just grabbing it. You know, just kind of mistaken identity.
Well, there are many ways you can get to a specific package on npm. One is searching on npm, but usually what people do, they listen to some public teaching sessions and they see that someone mentions that framework and they go using it on their own and mistakenly Google it or anything and land up on a malicious package. What's in this case, the attacker consciously, knowingly copied the entire description of the legitimate icon package and put it into his description. He also copied the name, as we already said, modified it just a little bit. The domains, C2 domains used inside the malicious code were also mimicking the legitimate domain used by Ionic.io. So the developer even put made the homepage on the fake domain looking the same as the official web page of Ionic.io. So the developer put a lot of effort to mimic and impersonate the real thing.
We did a blog post on this back when you first disclosed it earlier in the month, and included the screenshots of the pages for the ionicio.com page, which was the malicious page, and the ionic.io page, which was the page for the legitimate company that makes the icon package. Yes. And they look identical, slightly different wording, but unless you were really paying attention, it would be very difficult to realize that you were at the wrong place. This
you should do some navigation to detect
it. Interesting. And for development organizations out there that are tuning into this, what should their orientation be or their position be on this issue of we've got open source modules here that we're using, that we're relying on, and whether or not they have obfuscated code? Should it be just a hard line, like don't mess around with anything using obfuscated code, or it's something that should make you look a little deeper and figure out what's going on, but not forbid it altogether?
Well, me as a reverse engineer, looking at a large number of threats, my opinion is that you should never use anything that's open source package without looking what's inside of it, because putting malicious behavior has become very common. It's not just malicious actors. Authentic, legitimate developers get frustrated in some point of their life and decide to do some bad stuff. That can happen, and you don't wish to try your luck with using something freely available without looking at how does it work. I know that sometimes you need to have specific knowledge to see what some code does, but let's say I give you a present, I don't know, some pill, and tell you go drink it, it's okay. Would you really want to do that?
Probably I would totally do that.
You would want to see. Yeah. Well,
if you gave me the pill, Carlo,
it's okay,
I would do it.
Yeah. If it's okay, it's okay. I wouldn't lie. Why would I lie for you? So you should always, if you see obfuscation, that is a sign that you need to look at it better. Because you don't want to. Somebody tried to make something hard to see, so there is, I believe, 50% chance that they did it on purpose, especially if they put it into an open source repository and before putting it there, made it obfuscated. Why would you do that? Why would you put something publicly available? And there are legitimate cases, but most of developers which push code up to public repositories wish to share it. They don't wish to hide their functionality. So if you come across obfuscated package, anything in it obfuscated, check it, see. Generally, when you try to find a module that you can use for your purpose, don't go rushing, okay, I see this, it says it does this and that, okay, I'll download it, I try. No, don't do that. Check first and then try to use it, because there are a lot of modules that have post-install scripts and they perform some action immediately after you install them. So you don't need to actually use them in your project. They can already create some damage to you. So before you use it, double check it, because security should become everyday hygiene in your development
So
process.
you dug in, you found this code, you dug into, deobfuscated the code, and took a look at it. And just tell us a little bit about what you discovered. What was going on here that struck you as suspicious or malicious? What was this code designed to do?
Yeah, so I downloaded then one of the packages which I analyzed. Okay, I downloaded, used the publicly available deobfuscator for this obfuscator, and what came out, something looking like a legitimate jQuery, minified jQuery. Okay, why would someone obfuscate legitimate jQuery? That doesn't make sense. Anyone can download jQuery. You don't need to hide its functionality.
It's not proprietary code. It's not something that is intellectual property that you'd want to obscure. Right.
Yeah. Right. People use jQuery. Okay. You go scrolling, there's about 2,000-3,000 lines of beautified jQuery, and you go down, and you see everything looks like a legitimate jQuery. And if you go down deep enough, you come across hexencoded strings. Okay. What are these hexagonal strings? Something is suspicious. You go decode them, and then you come across malicious behavior. So what's up in this case? Someone took in one of the packages. In some other packages, the mechanics were different, but in most of the packages, they took legitimate jQuery code, hooked some of its functionality. In some cases, it was end function. In some cases, I don't know, several functions were depending on the package, hooked, and they added their behavior behind the legitimate behavior, jQuery behavior. So they didn't mimic the original icon set, they just put something else in it, in this case jQuery, and modified it with the functionality which collects form data and posts it to the controller's website.
And the rest of these packages were functional. They weren't going to break your application. They did what the legitimate packages they were modeled on, were supposed to do, but they just also can turn this.
When in most cases, they created elements, script elements, because the preferred usage of icons package is linking some script tags from content delivery network systems and use it in your web page. In this case, they add script elements regular and their own calling for their script from the same content delivery networks, UN, PKG, or something, whatever it was. There are other packages targeting other frameworks, not icons, but also other popular JavaScript frameworks like Umbrella.js, Swiper, Cider, or there are several other packages which were targeted, and the attacker tried to mimic them also. And for example, SIDR npm package hasn't been maintained for 6 years, but it has 500 daily or weekly downloads still. It's a very popular package, so it's a good target for impersonating, because probably someone won't notice it because it doesn't get updated. It's the same version for 6 years.
And for developers, the legitimate version would look like it's 6 years old, which would usually be disqualifying. And the malicious version would probably have a more recent version number and date stamp on it, which would make it look fresher, right?
Yeah, that could be. They could perform well. They could try, but in most cases, in this type of attack, it was just pure type scoping. They named it a bit different. Yes, they didn't go for very.
And this malicious code that you discovered, what was its purpose? What was it doing within the environments in which it was running?
Yeah, as I already mentioned, it wasn't targeting the developer of the application, but the end user. So when jQuery got loaded and everything, web page got generated and functional in the browser, when user visited this web page and entered trying to submit form data, username, anything on that form, it collected form data and upload it to the attacker-controlled domain. So it attacked all kinds of web pages wherever the module was used, collect, in some cases, generally searching for all form tags in the HTML page and submitting their content, serializing it and submitting it to the attacker-controlled server. So generally, in some types, modified searching for specific form data, but sometimes generally every form data present on the web page.
And this would have been indiscriminate, really any page that this module was deployed on would have been a target. Wasn't any evidence that it was targeted at specific organizations or sites?
Well, we have found, looking by the attacker names and account names, some clues that led us to the conclusion that one portion of this script was used in phishing attacks in the beginnings, back in December 2021. Arpan Risky, the user, published a script which was shared in some web tutorials explaining how to steal credentials and for PUBG online multiplayer game, quite popular in some Eastern Oriental countries. So that's one case when we found evidence of usage and linked it to that campaign. In my opinion, they were starting with collecting PUBG login credentials, Facebook login credentials, which were also used to log in on that pages, and later switching to NPM environment, a JavaScript environment, and broadening the reach, trying to catch all kind of login data, moving on from just PUBG game credentials.
Okay. What can organizations do to defend themselves from these types of compromises? Like you said, it's not targeting the developers directly, and that is not looking to get data or information out of the developers. It's really targeting the downstream users of the code, people who are filling out these forms on websites. But of course, it's doing that by way of fooling the developers into using the module. So as a development organization, maybe with a mixture of open source and proprietary modules that you're using, what's the defense against an attack like this? If you don't have somebody like Carlo Zanchi on your team, what do you do?
Well, there are various tools which can help you detect all kinds of threats. In this case, the threat is usage of bad dependency. What you can do, you can put some level of control on the modules your development team is using. It's like configuring your local mirror of NPM repository, gaining some insights and ensuring that you are capable to know what dependencies are being used and then performing security analysis over those dependencies. There are lots of tools. Some of them are better, some of them have limited capabilities, but there are ways to perform analysis of public repository contents, especially the one packages that you use. You don't need to scan the entire NPM to find malicious packages. You just need to focus on the dependencies which are used in your application. Perform security checks, see for malicious behavior, see for known malicious detections of those dependencies, and perform regular checks on the open source modules you use. It doesn't depend if it's from NPM. There are other package repositories. Their content is equally compromisable as NPM. So you need to check open source code you use. Don't go around, okay, this can be used for my needs, I'll use it. As we said, check what you use. And always you should check the final product, because there are some other places where your application inside your organization can get compromised. So you also need to check what you are
further
delivering
along
to the
in
final
the
customer.
development pipeline.
But in this case, this type of attack, the most important is to sanitize the open source modules.
Before we go to questions, I should let people know that we are going to take questions. And if you want to use the Riverside chat feature, you can pose a question for Carlo. It's not common to have somebody of his level of expertise at your disposal. So if you got questions on supply chain risk and attacks, use the chat feature and we will pass those along to Carlo. Carlo, since you initially discovered this, you have discovered additional packages. So, I mean, two questions. First is, what happened to the first group of malicious NPM packages that you discovered? Or have those been taken offline? And also tell us about what you've discovered subsequently. This IconBurst attack appears to be ongoing.
Well, the original set of packages which we discovered were all reported to NPM security team. They removed it in less than a week or even just a few days. But continuously new packages appear. The attacker creates new accounts, publishes new packages, primarily still focusing on icons package, but sometimes some other JavaScript packages or functionalities get spotted. What's important is there is no easy way to prevent someone from publishing to NPM because it's not hard to modify the content of JavaScript file, especially if you perform obfuscation on it. So there is no signature-based detection in this case. All files are obfuscated. Someone changes, it gets obfuscated, and the obfuscation can be a legitimate type of behavior, as we mentioned. So it's hard to detect it by automated analysis at the publishing time, so you need to check it when you use it. This type of attack can be expected to be present for some more time. Occasionally, probably new versions of malware will be published, as we seen it last week. A few new models appeared, so the end users should be aware of that threat. And as I mentioned, the easiest way to detect it is detection of JavaScript, of usage of JavaScript obfuscator. That should be the first red flag.
Final question: what do we know about that? You said these attacks are still popping up. What do we know about the individuals or group behind IconBurst and what the objective here is?
We don't know much. Most of evidence suggests that it's the work of one person, but it is possible that other malicious actors have bought these scripts from the original author. These are being distributed on various channels, and it is possible that several publishers are publishing to NPM. We believe that the initial author is linked to Indonesia. There are some evidence that suggests that the original campaign targeting PUBG users was sourced from Indonesian territory by Indonesian-speaking person. But in the meantime, we have no evidence of the final number of possible publishers to NPM and their motivations, what they are looking for. But what is sure is that they are targeting collection of user credentials.
And for organizations, just that this is a type of attack and a methodology that adversaries are increasingly aware of and using to their advantage, right? So this is something that you need to be attuned to. So I guess let me just say I think we're ready for question and answer now, Carlo. If you're up for it.
Yeah.
You sure?
Yeah.
I'm going to invite Carolyn into the studio. Carolyn's our producer. Hey, Carolyn, welcome back.
Hi, Paul. Hi, Carlo. Thanks for having me. My name is Carolyn Van Arsdale. I'm a producer for ConversingLabs, And I do have some questions for Carlo today. So, Carlo, are you ready?
Yeah, I'm ready. You can shoot
And
me.
while Carolyn's asking questions, if you are listening and you have additional questions, use the chat feature and we'll add them to the list. Go ahead, Carolyn.
First question for you, Carlo, is how is IconBurst different from other software supply chain attacks, such as SolarWinds or CodeCov?
Well, in this case, in the case of SolarWinds, the attackers compromised build infrastructure of the publisher of software, and they infiltrated through that vector. In this case, they aren't targeting the infrastructure of software developer through any offensive method. Instead, they are putting they are trying to make them use modules published by the attacker. So they aren't infiltrating their network or anything like that. They are just trying to lure them to use their packages for their functionality, and in that way get to the final customers of those software producers.
Okay, great. And next question for you, Carlo. What is the easiest way to search for obfuscated code in an NPM module?
Well, I do it by usage of our tools. We at ReversingLabs have a secure software platform which is continuously improved with additional functionality, helping you find threats. And in this case, we created indicator of behavior which can help you spot usage of JavaScript obfuscator. Basically, you should focus on behavior of the software. Behavior of the software can give you a lot of information about what you are going to use. So, is it using files? Is it testing file system? Is it using network ports? Is it using some known encryption algorithms? These are all known behaviors, and there are tools which can help you detect such behaviors. You should look for tools which provide you with this functionality, or you should try, I don't know, you can try to write your YARA rules or something like that. There are other ways to detect it, but I believe that the easiest way is to use tools which are good at it and which can help you detect it. They are not to reinvent the wheel, but use someone's good functionality.
Thank you. And next question for you. Should we refuse any NPM module that contains obfuscated code, or do legitimate modules sometimes contain obfuscated code also?
Yeah, as I already mentioned, you shouldn't refuse it. You shouldn't ban it if you see obfuscation in some module. You should deobfuscate it and see what's in it. There are legitimate modules which, for some reason, use obfuscation in NPM, but if you are using some other source for your modules, there are various third-party modules which have legitimate reasons why they obfuscate their code. So banning something because it's using obfuscation isn't going to
It's a
get
blunt
you far.
instrument.
Yeah, you can't just go and rub everything. You need to find out what's good, what's bad, and separate it.
Okay, got it. Makes sense. Next question, and this is going to be the last question as well. Are there ways to programmatically prevent typo squatting attacks like this, or is it just a matter of developer education?
Well, there are algorithms which can help you detect typo squatting. There are, if you Google it a bit, you'll find lots of algorithms which are good at this, but they are also not perfect. If they were perfect, public repositories would detect typo squatting immediately. So you can try and use some of your resources if you have spare resources to create detection for these types. But as much as I'm familiar with, currently this isn't working 100% good. I believe that you can't say it's bulletproof, and that if you program something to help you detect this, it will probably have some blind spots where it could leak, and if you rely on it too much, you could get yourself into problems.
And we talked about this with the dependency confusion attacks. If you've got internally developed modules that are non-public, we were saying it probably is worth your while to pay attention to newly created modules that might be mimicking those, right? If you, as much as you can, right?
Yes. In some cases, it won't be
Right.
typo spotting. There are different types of
Right.
attacks, so it's not always typo spotting. And I'm not sure if you wish to use your resources for each type of attack and
Right.
new attacks that will appear. So,
Carlo Zanchi, thank you so much for coming back in and speaking to us on ConversingLabs. This has been a great conversation, and I'm sure we'll have you back on again.
thanks, Paul, for calling me. Happy to see you again.
And for folks who are watching, we are recording this, and we'll be posting it on our website after the fact. So if you want to share it around in your network or come back and watch it again, it'll be on the ReversingLabs website. Yeah, so stay tuned for that. And thank you all very much. We'll be back soon, sooner than you might think, with some new episodes. And we're going to be at the Black Hat Conference as well, and doing some live stuff from there. So look forward to that in the weeks ahead. And Carlo, thanks. We'll see you again.